Okay, the next two problems are the special relationships, what we call either the sum or difference, meaning there could be a subtract sign there. In this case, it's a plus sign. Sum or difference of cubes. Some of you, we've done these already this year, but some of you have not, so I'll introduce it now. So here's what I'm going to have you start with. So this item is cubed. This item is cubed. Here's the procedure. The first thing you're going to do is you're going to take the cube root of both of those terms. So the cube root, those go away, and that leaves an x. Let me put a plus sign there, x plus y. All right. Then the second set of parentheses, here's the setup. It's the first item. So this is the first item. This is the second item in that first parentheses. So look at what we have. It's the first item squared. So x squared. You use the opposite sign. So if this is a plus sign, and it's only this one that's the opposite. This one is always going to be a positive. So we're going to put a subtract sign there. And then inside here, it's the first times the second. So x times y. And then we're going to add, it's the second thing squared. So the second thing is y. And then we just simplify that. X plus y times x squared minus x times y plus y squared. And just so you know, later on, when there's only one variable involved, this will be a real number solution, and this will be two imaginary number solutions. So if this is an x cubed, rather than it looking like this and touching the x-axis in three places, it might look more like something like this. So whenever you have the sum or difference of cubes with one variable, the graph will look something like that. Now, if it's a negative, it could look like this. Still, where it only touches the x-axis in one location, it could, the curves could be down here. Okay, so let's go ahead and get started. The first thing we're going to do is we're going to take the cube root of both of those. On your calculator, you type 3, you then hit the second and then that caret button that's over here, and then you type in the number and you press enter or equal sign. So the cube root of 125 is 5. And then you do the same thing, but you type 27, enter. You get 3, and then the cube root of u cubed is just u. So this is now our first item. Here's our second item in this first set of parentheses. So then when we expand this, it's the first thing squared. So 5 squared. You use the opposite sign, so this will be a subtract. Then it's the first times the second. So it's 5 times 3u. Then it's plus the second thing squared. So 3u squared. And then you simplify that. So this stays 5 plus 3u. Then 5 squared is 25. Subtract 5 times 3u is 15u. Plus 3u squared is 9u squared. So this right here would be the final simplification. Let's see if there's a subtract one. No. Well, yeah, it's okay. I'll just use this as example. So I'm going to do this one again. Well, I'll do this one. On your paper, go ahead and change this to a subtract. So we take the cube root of 8, which is 2. So if you do 3 for the cube root, type the second caret button, and this is on a T130. calculator. I don't know what other calculator you might be using. And then you type 8, enter, you get 2, and the cube root of m cubed is m. Whoops, I almost put m cubed. And then the subtract sign, and then the cube root of 27 is 3. So we have our first and second. Here's our first, here's our second. Now this time the operator is a subtract. So after we write the first thing squared, the opposite operator is an add. Then we write 2m times 3. Notice we don't put -3 here because we took care of the sign by changing it right there. Okay? Or actually, because of the setup, you just have to look at these things going together. You look at the second number always as a positive, and then it's the second number squared. So we end up with 2m subtract 3, and then 2 squared. So we have 4m squared plus 6m plus 9. This will be 2 imaginary roots, meaning there will be an I involved. And this one, the opposite of -3 is 3. The inverse of multiplying is dividing. So if I said I'd like you to graph that, so if this is 1, this is 2, halfway is 3/2 or 1.5. And I don't know exactly what it might look like, but it could look something like, let's see, we have to touch down there at -27. Oh, so this was not necessarily a bad way to do it. So I'm going to say down here is -27. So maybe the graph looks like something like, whoops, like that. All right. Sum and difference of cubes. That's it.